Suppose you encounter questions like, how many ways can you arrange letters A, B, C? This can be answered in many ways, like listing down all the elements, coming up with A, B, C, B, C, A, C, B, A, B, A, C, C, A, B, and C, B, A. Also, you can do this by making a tree diagram like the one you're seeing on the screen. The third way is by using the basic principles of counting. Now, suppose an experiment can be divided into R stages. If the first stage may result in any of n sub 1 possible outcomes, and if for each of these n sub 1 possible outcomes, there are n sub 2 possible outcomes in the second stage, and if for each of the possible outcomes of the first two stages, there are n sub 3 possible outcomes in the third stage, and if it continues, then there are a total of n sub 1, n sub 2, n sub 3 up to n sub r possible outcomes of the experiment. Now, let us illustrate this through examples. The first one is that, how many ways can you order a soup and sandwich combo meal and a salad in Joe's Diner, considering the menu below? Like what the basic principle of counting suggests, just multiply the number of meals possible. Thus, we have 6, which represents the soup and sandwiches combo meal, times 6 for the salad. We have 36. We are taking an experiment in 2 stages. The first stage, the soup and sandwiches, and the second stage, salads. Thus, there are 36 ways to order a soup and sandwich combo meal and a salad at Joe's Diner. In some problems, certain conditions were given. Thus, these restrictions should be satisfied. However, basic principle of counting still applies. For example, in the Philippines, license plates are composed of 6 different characters, 3 of which are letters and the rest are digits. Let's say Land Transportation Office wants to do an experiment, and for May 2011, all license plates will just contain vowels. How many different plates can be generated? As stated, we should satisfy the conditions given. Given this particular instance, always bear in mind the domain of each stage. For example, vowels composed of the letters A, E, I, O, U, which are 5 in cardinality. On the other hand, there are 10 digits all in all available for use, from 0 to 9. Just a tip, bars are indeed helpful. Now, let us look at the situation. On the first stage, we have 5 elements to choose from A to U. For the second stage, we have another 5, and another 5 for the third stage. For the fourth, we have 10 because we have 10 digits all in all. Same with the sixth and the fifth. Thus, multiplying 5 to 5 to 5 to 10, 10 and 10, we have 125,000. Thus, there are 125,000 possible plates to be generated using only vowels and digits. Sometimes, all elements need to be strictly distinct with each other, but still, basic principle of counting applies. For example, suppose I have a pizza to be divided to my 4 younger sisters, Anne, Aiko, Isel, and Aina. In how many ways can the pizza, which is divided into 4 parts, be divided if each is to have a pizza slice? Now, if Anna took a slice, she has 4 possible choices. So, let's write down 4. Now, since one of the slices is already with Anne, the next girl, Aiko, only has 3 possible choices. So, let's write down 3. On Azel's turn, there are only 2 choices left since the 2 girls already obtained the 2 slices. Now, we write 2 on the third bar. And for Aina, there is only 1 choice left. So, for the last bar, we write 1. Thus, multiplying all of these, 4 times 3 times 2 times 1, we have 24. Thus, there are 24 ways by which we can divide the pizza, all in all. Before we move on, let's first discuss what simple random sampling with replacement and simple random sampling without replacement are. First, simple random sampling with replacement, or simply SRSWR, is a type of random mechanization wherein all elements in the sample need not to be distinct. Thus, an element selected is replaced by an identical element. The next, simple random sampling without replacement, or SRSWOR, is a type of random mechanization wherein all elements in the sample need to be distinct. The next 2 problems are special cases. The first is conducted under simple random sampling with replacement, and the next is under simple random sampling without replacement. Also, the next 2 examples illustrate a special case wherein at least one element in the sample is defective or possesses a particular characteristic. Our first example is, suppose all 12 teachers in an elementary school, of which 8 are female and 4 are men, are to fill certain board of regent posts. If 3 are to be randomly selected, how many ordered samples with replacement will contain exactly 2 women? As stated, some of the elements are defective or possesses certain characteristics. For example, in the question, we require exactly 2 women to fill the posts of the regent. So, for a clear view, let us write down 3 bars. If the first member was elected and happens to be a man, then we write down 4 since there are 4 possible choices. When the second and third members were selected, we have 8 each. 8 since we are using simple random sampling with replacement, and since we require that there are exactly 2 women. Thus, there are 256 ways of selecting 2 women and a man to fill the board of regent posts under simple random sampling with replacement. Also, you can notice that if we happen to select a woman first, we'll write down 8 on the first bar. And if for the second, we also have 8, we'll again write down 8 since there are 8 women. And for the last, of course, we need a man, so we write 4. Since we have the same multipliers, we will have the same result. For the next item, we have a similar problem, only that we will do a simple random sampling without replacement mechanization. The problem: suppose all 12 teachers in elementary school, of which 8 are female and 4 are men, are to fill certain board of regent posts, and if 3 are to be randomly selected, how many ordered samples without replacement will contain exactly 2 women? Like what we did earlier, we write down 3 bars. If the first member was elected and happens to be a man, then we write down 4, since there are 4 possible choices. For the second, of course, we need a woman since we require that the sample will contain 2 women. Of course, we write 8 since we have 8 possible choices. However, on the third bar, we will just write down 7 since we are doing a simple random sampling without replacement mechanization. Meaning, since we've already selected a woman on the second stage, we just have 7 possible choices to choose from. Thus, we write 7. Multiplying all these 3, we have 224. Thus, there are 224 ways of selecting 2 women and a man to fill the board of regent posts under simple random sampling without replacement.